Welcome back. We're going to go ahead and take a look today at making Lewis structures. Now, Lewis structures are basically they're just very simple ways to go ahead and draw covalent compounds. So that's what we're looking at. A little bit of review before we start. We have to remember in a Lewis structure that a dot is an electron. Two dots that are shared is going to become a bond. So every dash represents two electrons. We also have to remember the valence number of electrons. Hydrogen is going to come in with one valence electron and the whole column. So the alkaline metals will all have one valence electron as well. Beryllium will have two, and family obviously, and the alkaline earth metals. Boron family will have three, carbon family will have four, nitrogen will have five, oxygen family will have six, halogens will have seven. Helium is a neon gas, or sorry, a noble gas, excuse me, so it will not make any covalent bonds, but helium is what hydrogen wants to be just like. Helium has two valence electrons. It only has one orbital, but that first orbital is filled when it has two electrons. So it's what hydrogen just wants to be like. And then neon is the next guy down in the noble gases. Neon has eight valence electrons, and that's what everyone else wants to be just like. Everyone else wants to abide by the octet rule. They all want to have eight valence electrons. So we're going to move on here. We're going to take a look at this. We're going to take a look at the process of how to make a Lewis structure. Now I do want to mention as well, there are many different ways to make Lewis structures. I'm making this video because I haven't found any good videos out there using this particular method, so I'm going to go ahead and post a video using this method. There's many methods out there though. I've seen three or four different ways to do it, and you as a student, if a different way makes sense to you, if a different way is even clearer to you, go for it, use it. I honestly really don't care. If you're in my class, I don't care what way you use, just figure out how to do it. I am posting videos of using different methods online on my Moodle site, so if a different way works better for you, go with it. Okay? So a process. First thing I want my students to be able to do is count the valence electrons. So carbon comes to the party with four Pepsis. Hydrogen comes with one, but three hydrogens will then have three Pepsis with them because Pepsi is so much better than Coke. Nitrogen comes with five valence electrons, and hydrogen comes with two valence electrons. We add all those together, we get 14. That means that we have 14 electrons that we can play with. Okay? Now, what are some hints? We have to draw the atoms, and we will always have hydrogen and the halogens on the outside of the atom. So you can see these hydrogens here. They're always going to be on the outside of the molecule. They're not going to be on the inside. Okay? We have to remember that hydrogen only needs two electrons to be happy because that fills its orbital. So it's good to go because it only has that one small orbital. Molecules are read left to right, and scientists, when they're writing the molecule, they will give you hints in their writing just to help you out. Okay, the atom with the strongest electronegativity goes in the middle, and one thing I'd also like to say is that carbon is almost always in the middle. If you got carbon, it's pretty much going to be in the middle. Okay, so let's go ahead and list them down. I'm going to start with the carbon, and I'm going to have these three hydrogens right here are going to be around that carbon. So I'm going to put a hydrogen out here, hydrogen on top, and a hydrogen below. So we have those three hydrogens there. Next I'm going to put in a nitrogen, and then I'm going to have these two hydrogens touching that nitrogen. So I'm going to put a hydrogen here, and we'll stick another one right there. Okay, so now what do we need to do? We have to fill in the electrons to make the atoms happy. Well, let's start with carbon. Carbon needs 1, 2, 3, 4, 5, 6, 7, 8 electrons to make it happy. Now these hydrogens that are around the carbon, we can see they are happy now as well because they are touching 2 electrons. Nitrogen is touching 2 now, so it needs another 6. That makes everyone happy, but let's see here. Yeah, the hydrogens are happy, the nitrogen's happy, the carbon's happy, and we only used 14 electrons to go ahead and make everyone happy. So we're pretty much good to go. The only thing we have to do left is make our bonds. Now, really, I would erase these electrons, but I can't do that right now. So we form our bonds. This right here will stay a free electron pair, and you are done.